Hello and welcome back to another Paper 2 walkthrough. This time it is for May-June 2023 and it's for Zone 2, as you can see here, 22. This is the first part and it will take us all the way up to the 15-mark question. So this paper should take us an hour and 45 minutes. It's worth in total 75 marks. As I said before, the last question, the programming coding question, is worth 15 marks. Here we go. Meaning this equates to only 20% of the final mark. So don't worry too much if you feel your coding isn't quite where it should be at this moment in time. 20% of the marks, there are plenty of marks to be picked up from the other chapters. One thing I do want to point out, remember, calculators must not be used in this paper. Okay? Tick one box, question 1. Tick one box to identify the first stage of program development lifecycle. Okay, so we've got analysis. Okay, copy that. Coding, well, no, that's right down at the end, along with testing. Design, well, maybe, but no. Correct answer is A, analysis. We've got to analyze a problem before we can sort of use computational thinking, such as decomposition, breaking it down into chunks before we begin. So analyze is the correct answer. Question 2. 4 logic gates and 5 standard symbols for logic gates are shown. Draw one link or one line to link each logic gate to its standard symbol. Not, yes, we can see all standard symbols will be used because there's 5 of them and there's only 4 of these. So we start with the AND gate. The AND gate is basically a big capital D, okay, with 2 inputs and 1 output. Whereas the OR gate is the one that looks like sort of a stingray going up. Now those lines, if you were to draw it like that, the examiner wouldn't quite know what you were doing. So, and that's always a problem with crossing lines, so I'm going to rub these out, and you need to do the same. Please do everything like this in pencil. Put the AND gate back in like so. Put the OR gate in like so. So do it as if you can see sort of a direct line going across. The NAND gate is basically not AND. So when we have anything that's got a not in it, it usually has a sort of a circle on the front. For example, this is a NOT gate. Okay, so because it's got that little thing on the front there. So the NAND gate is basically an AND gate, but with that little circle on the front. So that goes to there. Okay, so there are our links. Okay, so that's question 2. 4 marks for that. Question 3, I've identified 3 different ways that the design of a solution to a problem can be represented. Okay, so what do we think about this? Well, first of all, and what we're going to be using throughout paper 2 is something called pseudocode, which I hope by now you're familiar with. Pseudocode. Okay, it's only 3 marks, so we don't need to write anything more than the name pseudocode. Yeah, identify 3 different ways. So pseudocode, we're also going to be using in this a flowchart, and we might use something called a structured diagram. You may have come across top-down design, which is basically the same thing where we've got a problem and we're breaking it down into smaller areas. You may have seen in the book the satellite navigation system in a car where the inputs would be the addresses, the outputs would be the maps. You may get away, but it's not on the mark scheme, with a bullet list, but I would stick with those 3, or if you don't do structured, if you're not familiar because your teacher teaches you top-down design, as opposed to structured design, they are both the same thing, and you will pick up the mark for that. Okay, now we have a little program. Describe the validation checks that the programmer would need to use. Okay, so what's the program? What do we need to write? A program needs to make sure that the value input for a measurement meets the following rules. The value is a positive number. Okay, a value is always input, and the value is less than 1000. Okay, so validation checks. What can we check? We can check to see if somebody has inputted a number. We can check if they're typed in characters or numbers, if it's in the correct format. We can check how many numbers, such as a ATM PIN code. We can check the range if it is between a certain range. There's lots and lots of different checks. So how do we check that the value is a positive number? Well, for that we could use a range check, and it's 3 marks. range check. Numbers greater than 0 and less than 1000. Okay, so that would be our range, greater than 0 and less than 1000. We could do a presence check to see whether a value has been inputted. Ensures that code will only continue when a number is entered. Okay, so underline these. Range check, presence check. The value is less than 1000. Well, I've just said that up there. Yeah, so that would get us that. But what else can we use? A length check, maybe. So length check could be numbers equal no more than 3 digits. If it's less than 1000, yeah, e.g. 999. Okay, because a thousand's obviously 4 digits. So length check, presence check, and range check would give us the 3 marks there. The program needs editing to include a double entry check for the value input. State why this check needs to be included. Well, it's like a double check, but I've got that there, so I can't write double check there. So what I would do is to verify, because we're talking validation, that the data is correct. Okay, keyword there is verify, validation. First entry must equal second entry. Okay, so that's what we do there. The input value, and that's only worth one mark. The input value needs to be stored in a variable measurement. Write pseudocode, first time, okay, to perform the double entry check until a successful input is made. The best way to do this is use something called a repeat until. So we're going to repeat, okay, something until. So what do we need to work out? We're going to repeat until. The input value needs to be stored in a variable called measurement. So let's put in the word repeat, yeah, and then we're going to repeat what? We're going to repeat output, okay, what we're going to output. Please enter measurement. So the input is measurement, i.e. the variable, stored value, okay. So output, please enter measurement, input measurement, and then again, it's just output, please re-enter. It's as easy as this, measurement, input, but we'll have a second variable here, measurement 2. Okay, so we check against that. So we repeat output, please enter measurement. We input the measurement. Output, please re-enter a measurement. Input measurement 2. So, and repeat is where we have the until. Repeat until measurement equals measurement 2. Okay, and that's it. So that would give us 3 marks. It's a lot easier than you think, but you need to know these repeats and repeat untils. It's all in my videos on pseudocode. Please take a look. Okay, question 5. Now, I believe this has been removed from the paper. It was during COVID times, remember, or just after COVID times, and for some reason this question was removed. But circle 5 file handling operations. It's on the paper, so I'm going to do it. Circle 5 file handling operations. If you think about reading and writing files into your code, write, and it is another one, read. So reading and writing files into our code. But then what do we do? Well, we've got to open and close these files. So we open it and close it. But then what else can we do? Calculate? No. Output, print, test, total, count, sort, search, input. These sort and search, total, are all based on the data. All we need to do is handle the file itself, not the data within the file. So we're going to create a file. Okay, that would be our 5th one. Close, read, write, open, and then finally create. Okay, but it is quite an obscure question. They're not really sort of, I mean, it's a very short question for it to be asked, but that's basically it. Now, question 6, state 3, only 3, different, let's see how much it's worth. Okay, 6 marks for this. Okay, state 3 different features of a high-level programming language that a programmer could use to make sure that their program will be easy to understand by another programmer. Give examples for each feature. Well, I think if we put the features in, then we can go back to the examples. Now, your teacher should have told you this, but you would do something like use comments throughout. Okay, hashtag, if it's in Python. Feature 2, what could we use? We could use functions and procedures. It's basically the same thing. Okay. And then finally, we would use meaningful names, arrays, constants. Example. I'll draw on something we've used in the previous question. Repeat until valid number is entered. Use functions and procedures. We could do calculate average, totals, all values, divides by number of values. And then meaningful names, names equals surname, first name, user. Okay, so that's the sort of thing. So use comments, use functions, and use meaningful names. Okay, so that would be question 6. Now we have our first coding question. An algorithm has been written in pseudocode to calculate a check digit for a 4-digit number. Okay, the algorithm then outputs the 5-digit number, including the check digit. The algorithm stops when -1 is input as the 4th digit. Part A, we've got to look at totaling, count controlled loop, and post conditional loop. Okay, so let's have a read through this. Okay, so line 1, flag. Something called flag has been issued, given the value false. We then repeat. Okay, so repeat. We've seen this, repeat until. So all this code is going to be repeat until flag. Yep. So total has been assigned the value 0. For counter has been assigned the values 1 to 4. Output, enter a digit into the counter. Okay. Input number into the counter. Total equals has been assigned the value total plus number times counter. Okay, since it's a bit odd. Okay, if number counter equals 0, then flag becomes true. Well, I know that's wrong. Okay, that should be -1. So I'm just going to make a little note there. That should be -1, not 0. Okay, end if. So that little statement there. Next counter. If not flag, then number 5 is a modular, the total 10. Counter has been assigned the values 0 to 5, output numbers in counter. Next, end if until flag. Okay, so let's have a little look. We need a line that represents, and all we're doing here is showing numbers, the line numbers. So, totaling is on. Let's have a little look. It gives it away really. 0 total, yeah, has been assigned the value total plus number times counter. So total is on line 0, 7. Yep. Count controlled condition. So we need to look for counting. Okay, we've got some counting down here, and on line 12, counting at line 5, counting at line 4 for counter. So we're setting a counter here. Yeah, we're setting a counter for counter. Has been assigned the values 1 to 4. Okay, so that starts there, but where does it end? There, next counter. So we're looking at 04 to 12. Are there any more counters? Okay, so yeah, we've got a counter here. For counter has been assigned a value 0 to 5 for the 5 digits, and then we've got a next to end the counter. So we've put in there 16, 18. A post-conditional loop, well, that's basically what I mentioned at the beginning. Where it starts, 0, 2, it repeats until everything has happened, what we needed it to happen, i.e. -1 has been entered into here. So that is our post loop. So that would be 0, 2, 20. Okay. Now we might have to do some jumping around here. I can see what part B is. We already spotted one of the errors. Identify 3 errors in the pseudocode, yeah, and suggest a correction for each error. Error 1, error 2, and error 3. Is that it? 3 errors? Yes, 3 errors in the code. Let's have a look. Flag has been assigned the value false. That's fine. Repeat. Total has been assigned the value 0. For counter has been assigned the value 1 to 4. Output, enter a digit, counter. Okay, starting counter. Input, number, counter. Okay, number, counter. Okay, so we've inputted number to go into the counter. Total has been assigned total plus number times 4. Well, we should be assigning to the list counter to the array counter. So although we've got counter here, we need to put in number counter here. So that should be number, like on line 6, number counter. Okay, because that's how it stores it. the array is called number. The values within it are the counters. Yeah, i.e. output enter a digit counter. I hope that makes sense. So it should be number counter rather than just number. So that's line 7. And again here, if you remember, we put here, if number counter equals 0, well, no, it needs to equal -1. So this is a problem here. It should equal -1. So question 7 is a problem. Question 8 is a problem. Yep. So let's move on. The flag equals true, end if. Next counter. If not flagged, then number value 5 has been assigned the mod total 10. For counter has been assigned the value 0 to 5, output number counter. Next. I'm just having a little look at this. For counter has been assigned the value 0 to 5. Well, 0 to 5 is 0, 1, 2, 3, 4, 5. So that basically would equal 6 values. So we can't have that because at the top here it says 1 to 4. So we need to put in 1 to 5. Okay, so rather than it being 0 to 5, line 16 should be 1 to 5. So that's basically it. So let's try and remember what we've written. Yeah, so I can just try and do this in order. So the error was line 7, and its total has been assigned the value, total has been assigned the value total plus number times counter. That's probably the hardest one, where it should be, line 7 should be total, assign the value total plus number, because it's already in the code, counter, okay, times counter. And line 8, which we established was if number counter equals 0, should be line 8, if number counter equals -1. Okay, and then finally, line 16 for counter has been assigned the value 0 to 5, should be 16 for counter should be assigned 1 to 5. Okay, so there are the errors. Is that it? Oh my word, no. The algorithm does not check that each input is a single digit. Identify the place in the algorithm where the check should occur. Write pseudocode for this check. Your pseudocode must make sure that the input is a single digit and checks for -1. Okay, where are we going to put this? Let's have a look. So input number, okay. So line 6, input the number counter, and then we're going to do the totaling. This, where the person is inputting, we could have a check here, validation. Okay, so going in between line 6 and line 7, check that input is correct. Okay, so input number counters, what we're going to put in here. We know where we're going to put it. We're going to put it as a new line 7. Okay, but what we're going to do, well, I'm going to use again for this, I'm going to use the repeat until. So we're going to go round and round and round until it does it. So repeat, we're going to output, enter, so as before, enter a digit, okay, and then that number, when it's input the number, yeah, store it in counter, okay, but they're going to do that until number counter. So we must make sure that the input is a single digit, okay, this is what we're looking at. Okay, so repeat until, so this is going to be quite a long line. I'm just hoping I'm going to be able to fit it on. Let's have a little look. So repeat until the number counter equals a single digit. So I'm going to round, in this case, probably the easiest way of doing it. Round number, okay, counter, equals 0, okay. Basically, no remainders, it's rounded to one whole number. And, so a single digit, yeah, rounded to, that's the important thing. Yeah, so numbering counter is one single digit. And let's have a little look at this. Number counter equals -1. Okay, so output enter a digit, input number into the counter, repeat until the number in the counter is rounded to one sort of character, and number counter equals -1. I think that will do. For this, we could do with an alternative. So I'm just going to put in here, or let's have number counter is greater than 0 and then we've got to do it like this. Number counter is less than 10. And because we've got that in brackets, we need to put it in brackets. Okay, so there we go. So we've got a little OR statement there. Hopefully you can make sense of that. Question 8. Okay, we've not got a diagram for this. We've got a x equals A or B and not B and C. Okay, so I'm going to put X in here. I'm going to draw this. I'll say because you can see it a bit better. So because we've got 4 gates. Okay, so the one in the middle, the one that joins these two together, the AND, I'm going to put here. So we'll have an AND gate here like so. Okay, and then I'm going to put the A, B, C down here. So A or B, so let's put an OR gate in there. And that's going to go to B and A, and that's going to feed into our slot there. But then we've got another AND gate, yeah, which is this one here, but we've got not B. So I'm going to put a tiny little not in there, not B, and that's going to go into there. C is going to go into the AND gate, and that's going to go into the other AND gate there. So we've got two AND gates. We've got a little tiny NOT gate, see that, making it worse, and we've got an OR gate. So that might help us along the way, because we need to get to X here. We need to work out what this column is going to be here, and it's for 4 marks. But as you can see, 1, 2, 3, 4, 5, 6, 7, 8. So I believe, putting the mark scheme, every 2 we get right, we'll get a mark. How are we going to do this? Well, A and B, A or B needs to be 1 here in order for this to be on, and it needs to be a 1 here in the AND gate. So 2 ones would make it work. Okay, but let's go through this and see. I'm just going to change the color so you can see it a bit better. Okay, I've tried to make the diagram a little bit better, but not. So let's have a look. We need to work out A and B. That's fine. If either B or A are on, then I'm going to put a 1 in here for D. So if either A or B are on, then D will be on. So let's work out D first of all. So let's put a column in here, and I'm going to do D. Now D basically, as we said, if A or B are on, so no, no, yes, okay, yes, 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 and then if both on, all works in the way whereby it will accept both values being on, so all of those are okay. Yep, but now if I go to E, E will be the opposite of B. Okay, so NOT gate basically is the same as an inverter, and B would become, if B is 0, it will become 1 when it passes through the NOT gate. So let's put in E. Okay, so basically, yeah, as I say, it inverts it. So when B is off, it will become on, off, off, on, off, off. Okay, this is an AND gate at the bottom here. Okay, and we've got E and we've got C values. So C and E need to be on in order for this here to be, and I'm going to call this F in order for F to be on. So let's put F in here. Okay, so we're looking at C and we're looking at E. So C is off, E is on, so that's on. C is on and E is on, so that's 1. Off, off, on, off, on, off, off, and on, off. So we've got 2 values, yeah, 1 and 1. So now D and F need to be on in order for X to be on. So let's have a look. D and F are both off there, so that's off. D and F, yeah, no, 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 no. Here we go. 1 here, so that one's on. 0, 0. So we've got it. So everything's off apart from that one is on. Okay, so only one value is on. So that's question 8. So that will get you 4 marks for filling in that column. But please, there is working space, and there is working space for a reason. Please use it. Okay, so let's have a little look at question 9. The flowchart represents an algorithm. Okay, part A. The array X, which contains 5 values, used in the flowchart contains this data. So position 1 has got value 10, position 2 value 1, position 3 value 5, position 4 value 7, and position 5 value 11. Okay, and they've been populated into this first row: 10, 1, 5, 7, and 11. These different values. So let's have a look through the algorithm. We don't know what it does yet and what it does with these values. So let's have a little look and see. We'll do one run and we'll see if we can work it out. So we're going to start. Okay. First of all, F has been assigned the value 0. Okay, C has been assigned the value 1. That's fair enough. Is XC, this might confuse you. It's basically saying position. We're using C as a placeholder, as a position. So XC, or the first position in the array, which is basically 10 here, look. Is 10 less than C plus 1? Is it less than 1? Well, no, it's not. So let's have a little look here. So T, total, becomes the value in XC, okay, which is the first place, which is going to be 10. So total, or T, becomes 10. Position 1, okay, this position here, gets assigned the value C plus 1. So this one now becomes, okay, basically taking it from position 2. And so that's that one. C plus 1, okay, so position 2 gets assigned the value which is in total, which is 10. So 1 and 10. So basically those two numbers have swapped. Okay, we've swapped those two around. My thinking is this is a bubble sort. Okay, if we're swapping numbers around, we must have a bubble sort. F is assigned the value 1, and C is assigned the value C plus 1. So 1 plus 1 is 2. Good. Is C equaling 5? Well, no, it's not. So we go back up and we repeat the process. Is position 2, which is 10, is that less than position 3, C plus 1, which is 5? Well, no, it's not. So let's have a little look. T total gets assigned the value which is in position 2, which is 10. So total goes in there. So 10 again, look. Keep putting dots in so you can see. XC, so okay, position 2, what's that? 10. Yeah, that gets assigned the value 2 plus 1, which is 3, which would be 5. Okay, this position here is a 5, gets put in there. Position 3, which is basically 2 plus 1, so position 3 down here gets assigned the value that's in total. So that gets put in position there. F gets assigned the value 1 again, and C is C plus 1, so 2 plus 1 is 3. Okay, does it equal 5? No, it doesn't. So we'll back up. Is XC, okay, well, let's have a look. Is XC, so that's 10, this one here, yeah, is a value in the third position. Is 10 less than 7? Okay, no, it's not. 10 is not less than 7. So total then gets this sandy value that's in position 3, which is 10. So that gets 10 goes back in there. XC, okay, position 3, 10. Is that less than that? No, it's not. XC plus 1 gets assigned the value that's in there. So 7 goes in there. Okay, so XC gets assigned the value. So position 3 gets assigned the value that's in position 4. So it gets assigned the value 7. XC plus 1 gets assigned the value. So position 4 gets assigned the value that's in T. So that's 10. Okay, so we're getting some kind of order going on now. Let's assign F as a value 1 again. C gets assigned the value 4. Is C equaling 5? No, it's not. Okay, so we're going back round. Does position 4, 10, is that smaller than the value that's in position 4 plus 1, position 5? Is it smaller than 11? Well, yes, it is. So yes, we're here now. We've got the first yes. So let's have a little look. C equals C plus 1 is 5. Okay. Is C equaling 5? Yes, it is. So is F equaling 0? Well, no, it's not. So back onto this bit. No. So we're repeating. We've gone round it all once. We've gone round all the values once. 1, 2, 3, 4, 5. All the positions have gone round once. Okay. So now we're going to assign the value F as 0 and C as 1. Okay. Is position 1, okay, up here, is position 1 less than the one that's in position 2? Well, yes, it is. So C gets assigned the value here. Does C equal 5? No. So back round again. Is the value in position 2, 5, is that less than 7, which is in position 3? Yes, it is. So C gets assigned the value C plus 1. Does it equal 5? No, it doesn't. Let's go around again, check it again. So is, where are we now? Position 3, 7. Is 7 less than 10? Yes, it is. So I guess assign the value 4. Does it equal 5? No, it doesn't. Let's go back round again. Is position 4, okay, 10, is 10 less than 11? Well, yes, it is. Okay, so let's put 5 in there. So it looks like we've got some 1, 5, 7, 10, and 11 are all in order. C now becomes 5. Is C equal to 5? Well, yes, it is. Is F equaling 0? Well, yes, it is. So therefore, the algorithm stops. Okay, so it stops there. Looking at this, we've sorted out 10, 1, 5, 7, 11 into position 1 has now become 1. Position 2 has now become 5. Position 3 has now become 7. And position 4 has now become 10. Position 5 has stayed the same at 11. Okay, so it's a sorting algorithm, a bubble sort, comparing pairs. Okay, comparing the previous and the next value in the array. Okay, I recommend doing this in pencil first, and then once you're happy with it, fill in the gaps. Okay, for part B, we're going to describe what the algorithm represented by the flowchart we've just done. So, as I said whilst I was doing it, we worked out that it was a bubble sort algorithm. Okay, bubble sort algorithm. But that would probably get us 1 mark. What we need to do is say how did it do it? Well, it did it in ascending order. Okay, numbers put in ascending. Is it double C? Ascending? Ascending order. Okay, so that would get us the marks. Question 10. Okay, looks like we've got a little mini database here. A music streaming service has a new database table called Songs. That might be important. To store details of songs available for streaming, the table contains fields. Song number, which looks like it's going to be unique. Yeah. Title, the title of the song. Okay. Author, the name of the songwriter. Singer, the person who sang it. Genre, the type of music, for example, rock. Minutes, how long the length of the song is in minutes, for example, 3.75. And recorded, the date the song was recorded. Okay. Identify the field that would be most appropriate for a primary key. Well, we've just got the example there, haven't we? So it's going to be the song. And please do it so it's got a capital in there. Look, so song number. That would be my first choice. Okay, complete the table to identify the most appropriate data types for the fields in song. So song number, we've got a mixture of letters and we've got a mixture of numbers. That would be a text. Okay, you get away with text. I know, but some teachers you might be taught alpha. So you spell it numeric. So it's a mixture of numbers and letters. But yeah, text is fine. Title, title of the song. Again, that's just going to be text. Okay, because it's a string of letters. Okay, we can put in there again alphanumeric. Recorded, the date. So that's a date field, isn't it? So it's a simple date field. If you want to be right about it, date and time. Okay, although it just says the date on there, but it's date and time. And then minutes. Minutes you would be looking at, because it's a decimal number. Okay, it wouldn't be an integer. It would be, in this case, and not float. Don't put float down because that's Python. You would put real number. Okay, so that will get you 2 marks. Part C. Now we've got some SQL, and this is all you'd ever need to know in terms of SQL, but you're going to need to know a little bit about it. Explain the purpose of the structured query language SQL statements. Some, so we're totaling here, some minutes from song where genre equals rock. Okay, and then count the titles, number of titles from songs where genre equals rock. Now, don't get confused because this is not the table. Don't, because there's obviously there's no data in this. So we're trying to work out what this one and this one means. So some minutes. So basically, what we need to find a total. Find the total of what? Total of minutes of rock songs in the database. So to find the total number of minutes of rock songs in the database. Okay, and then count title from songs. Find the total number of rock songs. Okay, count the title from songs where genre equals rock. So yeah, to find the total number of minutes of rock songs in the database, yeah, and to find the total number of rock songs. Question 11. The variables p and q are used to store data in a program. P stores a string, okay, and q stores a character. Write pseudocode statements to declare the variables p and q store the word in p and w in q. This is how we would do it, and you might need this when we get onto the final one. We're going to declare, okay. I'll do this in capitals. Yeah, we're going to declare. Okay, what we're going to declare? We're going to declare, first of all, P, yeah? And what does P equal? Okay, P equals the word. So declare P. But what we're declaring P as? Well, P is going to be a string. So declare P, and we put a colon here, and we put that as a string. So, but what is in that string? Okay, so P has been assigned, got an arrow in here, and it's been assigned the value the world. Okay, and then we do the same with Q. So I'm going to declare Q, like so. Declare Q as a what? Well, it's told me there's a character. So character, we don't need to write the full character. We just put char in. Okay. Declare Q as char, and then Q, and I can't fit it in there. I'm going to fit it in here. Q has been assigned the value what? It stores in W. Okay, in capitals. So that's basically it. Okay. I declare what P is. It's a string, and I put it as the value in the world. I declare Q as a character, and I put the value in W. It's as simple as that. Okay, nice and simple. It does get a little bit harder here, and this is why it's worth 4 marks for part B. What we're going to do now, so we know that so the world is stored in P, W is stored in Q. Write a pseudocode algorithm to convert P to uppercase and find the position of Q in the string. The first character in this string is in position 1. So going back, yeah, as I've just put in here, 1, 2, 3, 4, 5, 6, 7, 8. There's 9 characters, yeah, and W is at position 5. Okay, but we've got to write pseudocode to prove that. In fact, if we have a little look here, give the value for 1 mark, give the value of position. Well, it should be 5. Let's hope it is 5. Okay, but that would give us 1 mark there. But let's not jump the gun. Let's do it properly. So, how would I do this? Convert P to uppercase. Now, this is a bit of a there's many different ways of doing this, and I think in the book it uses UCase. Okay, I would just use uppercase. It still gives you the marks. It doesn't make a difference. So P. So let's get this right. So let's declare the thing P equals uppercase. Okay, but then we've got to put in brackets P. So everything in P it should be uppercase. Okay, so P has been assigned that value, but made a mistake already. P has been assigned the value uppercase. What's next? We're going to bounce through the world. Yeah, we're going to bounce through it until we get to a W, which has been stored here in Q. Okay, so we're going to repeat until basically. So I've stored that, and I'm going to repeat until, and I'm going to set a counter value until a counter, because I'm going to count 1 at a time, is greater than the length of P. Okay, so I'm going to repeat until the counter that I'm going to be counting every time I go through and adding 1 to it is greater than the length of P. Let's go. If position char, yeah, if position char, I've created a little variable there. If position char in P, okay, is same as counter, then position equals counter. Okay, then position equals counter. So I think I've got position. Yeah, position equals counter. And then I would stop. So I'm going to put a break in there, and I would end the if. Okay. Okay. But if it doesn't, then it's going to loop around again, and I'm going to put counter equals counter, and then end, repeat, and repeat. Okay. So we're going to repeat until the counter is greater than the length of P, and then we're going to check if the current position matches Q, matches the value stored in Q, which is W. So if position P, checking if the match, okay, checking if the match, then the variable position, which I've put, let me make that a bit more obvious, position equals counter, okay, break. End the if statement, everything's good in the world. If that equals that, then we break the program, end if. Counter equals counter plus 1, and then we end repeat. But what it's not doing, which I'm surprised about, stop position Q in the position, I'm going to just add at the end output position. Okay, output position, and it should, because we did it a little bit ago, output position, yeah, and that will give us the value 5. Okay, so that's it. Okay, a little bit of confusion there, but that is it. We're going to have a little look at question 12 and the 15-mark question.
Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.